We're not back. So, thank you for keeping up with me, staying with me. This is part 3 of the unit circle. We had to break part 3 so that the videos will not be so long. What I just did was I erased that of 30 degrees, reference angles of 30 degrees. I erased it so that we could do 45. And after doing 45, we do 60. And that's it. 90, we've already done 90 because the 90, the quadrantal angles are included in the 90. Alright, so let's look at 45 degrees as we talked about initially. 45 times 1 is 45. 45 times 2, this is 90 degrees. Of course, we've done 90. 45 times 3 is 135 degrees. So we need to do 135. 45 times 4 is 180 degrees. We've done 180. 45 times 5 is 5 times 5 is 25. 5 to 22 to 5 degrees. We need to do that. 45 times 6 is 270 degrees. We've done it. 45 times 7, 270 plus 45 is 315. 315 degrees. We need to do that. 45 times 8 is 360 degrees. Right? So we've done that. So we got 135, 225, 45, 135, 225, 315. All right, let's see how this will work now, folks. Let's see how this will work. Let's draw our circle as usual. We are doing reference angles of 45. Okay, we want to do reference angles of 45 and see how it looks like. This is still the origin. This is 45. Let me make sure it's just half of it. 45 degrees. And we found this to be what? Root 2 over 2, root 2 over 2. Right? So this is 45. Remember, reference angle, like we talked about in part 2, they are the positive acute angle. Positive acute angle that the terminal side of the angle makes with the x-axis. X-axis could be positive x-axis or negative x-axis. Now this one will be 45 also. Here, 45. Then this is 45. 45, and then this is 45. All right, let's find the reference angles. Let's go ahead and find the reference angles. We have the 45 degrees here. The next reference angle is gonna be this. Okay, gonna be this. So this is 90 plus 45. That's 135 degrees. So we will get our 135 degrees. We'll get it. Then the next reference angle will be from here to here. That is 180 plus 45. 180 plus 45 is what? 225. 225 degrees. This will be 225 degrees. And then the next one will be from here to here. There. This is 270 plus 45. Will give you 315 degrees. 315 degrees. Alright, so the reference angles for 45 degrees are 135 degrees, 225 degrees, and 315 degrees. So we can go ahead and find these three right away. Now, as we did the other time, this is what? What is this now? This is the second quadrant, which means x is negative, but y is positive. So this is negative root 2 over 2, then root 2 over 2. X is negative, y is positive. Here, both of them are negative. negative root 2 over 2, negative root 2 over 2. Right? And then here, x is positive, y is negative. Right? So this will be root 2 over 2 and negative root 2 over 2. Okay? Alright, the work is now simplified for us. The work is now simplified for us. We have that 135 degrees. What is it going to be? Now let's convert it. So 135 degrees x. So this means that what? 180x is equal to 135 pi. So x is 135 pi over 180. 5 into 13 is 2 times 5. 2 times 5 is 10. 35 is 7. 27 pi over 5 into 18. 3 times 5 is 15. 30 is 6. 36, right? 3 can still go. 3 into 27 is 9 pi over 12. 3 can still go again. I would have just done 9. Come on now. So this is 3 pi over 4. Right? 3 pi over 4. 45 times 3, yeah. 45 times 3. And you can do it this way. Look, folks, you can also do it this way. You know that 45 is pi over 4 though. You know? 45 is pi over 4. So this is 3 pi over 4. You can do it that way. And even 225, you know, because if you don't want to do it, you know, we keep learning. We keep learning, right? If you don't want to do it by conversion like this, you could just do it this way. We know that 45 is pi over 4. We know that 45 is pi over 4. Pi over 4. So 135 is 3 pi over 4. 225 is what? 5 pi over 4. 5 pi over 4. Do you understand what I'm doing? That, I mean, saves time. Then 315 is what? 315 is what? 7 pi over 4. Saves time, buddy. Saves time. Saves much time. 7 pi over 4. Okay, folks, let's now finish this up. Sine pi. Sine 135 is y. Y. Right? Y is root 2 over 2. And if you want to simplify this, you can just put here xy. Okay? Just put it xy. So, not to confuse you. Not to confuse you. Cos 135. That's a negative now. Negative root 2 over 2. Tan 135, of course, this is going to be negative 1. Negative 1 because of this negative. Cosec 135 is 1 over y. 1 over y. So this will still be root 2 because it's still positive. Sec 135 is 1 over x. Sec 135 is 1 over x. So it's a negative. Okay? And that's going to be what? Negative root 2. Are you with me? Rather than coming to do, you know, because this is negative 2 over root 2, which is negative 2 root 2 over 2, which is negative root 2. Then cotan x over y. So we got some negative here. So this will be negative 1. Negative 1. See that? That is for 135. Okay? Now for 225, sine 225 is y. This is negative root 2 over 2. Cos 225 is x. Negative root 2 over 2. Tan 225, of course, negative divided by negative is positive 1. Cosec y. This will be negative root 2. sec, this will be what? Negative root 2. And then cotan, negative divided by negative, because, or 1 divided by 1 is 1, or negative divided by negative, negative x divided by negative, because this is x is negative, y is negative, so negative divided by negative will give you positive. Okay? These are negatives because the x and y are negative. Okay? Let's check to make sure, double check, double check. Now, 315, which is 7 pi over 4, sine 315 is the y, negative root 2 over 2. Cos 315 is the x, which is root 2 over 2. Tan will be a negative. Tan is going to be a negative because y over x. Something is negative and something is positive. So this will be negative 1. Cosec 1 over y is going to be negative. See that? Negative root 2. From here. Sec 1 over x. Sec 1 over x. X is positive there. So this is going to be positive. This is positive root 2. And then cotangent x over y. 1 is positive, 1 is negative. You have negative 1. That is it, folks. That is it for 45 degrees. Okay? Now let's get out of 60 degrees before we call part 3. Before we call it a 9. Alright, folks, this is 60 degrees. Now let's go ahead and find the remaining angles for 60 degrees. We have 60 degrees. 60 times 1 is 60. 60 times 2 is 120 degrees. 60 times 3 is 180 degrees. We've done this. 60 times 4 is 240 degrees. We've not done it. 60 times 5 is 300 degrees. We've not done it. 60 times 6 is 360 degrees. We've done it. So we need to find 120, 240, and 300. Let's get our reference angles of 60 degrees. So we draw a circle. We have our quadrants. 60 is about here. 60 degrees. Okay, 60 degrees. And what did we have at 60? Remember what we had at 60? Sine is y and cos is x, right? So this is 1 over 2, then root 3 over 2. That was what we had at 60, right? Cos 60 is 1 over 2, and sine 60 is root 3 over 2. All right, let's go ahead and get our reference angles here. This is 60 here. This is 60 here. This is 60 here. Okay? And let's see what these angles are. 60. Then we have, let's use this one. We have from here to here. You know, this is that is 90 plus 30. So this is 120 degrees. 120 degrees. Then we have from the initial side to here, all the way here. So this is 180 plus 60. This is 240 degrees. 240 degrees. Those are the reference angles of 60. Yeah. And then we have from here, from the initial side up to the terminal side here. So this is a 270 plus 30, and that will be what? 300 degrees. Because this is 270, this 30. So 270 plus 30, 300 degrees. Okay, and then that is what we want to find anyway. 120, 240, and 300. And 300 here. Okay? So we have our 120 degrees. We have 240 degrees. And we have 300 degrees. Alright folks, let's write it. What is the pi? If you want to save time, 60 is pi over 3, right? So this is 2 pi over 3, 2 times 60, which is 2 pi over 3, 2 pi over 3. 240 is 4 times 60, which is 4 pi over 3, 4 pi over 3. 300 is 5 times 60, which is 5 pi over 3. 5 pi over 3. Easy. See? Makes it easy. Alright, 120. Let's get it done. This is in the second quadrant. Second quadrant, x is negative. Y is positive. This is negative 1 over 2. And y with 3 over 2. Okay? Then 240 degrees is in the third quadrant. Third quadrant here, both of them are negative. Negative 1 over 2, negative root 3 over 2. And then 300 is the fourth quadrant. Fourth quadrant, x is positive, y is negative. So 1 over 2, comma, negative root 3 over 2. Alright, we can now finish this right away. Sine 120 is what? Y. We can go ahead, put x, y, x, y, x, y. Sine 120 is y, which is what? Root 3 over 2. Cos 120 is x, which is negative 1 over 2. Sine 120, if you divide it, you have positive divided by negative. Y divided by x. Something is positive, something is negative. This is negative root 3. Cosec 1 over y. Y is positive, so we are good. So this is 2 root 3 over 3. Sec 1 over x. X is negative, so this will be negative 2. Cotan x over y. Okay, 1 is negative, 1 is positive, you still have negative. Negative root 3 over 3. See that? And you can check this with your calculator to see whether it's right. You can do that. 240 degrees. Back to you. Oh, this is negative, negative, right? Negative for the x, negative for the y. Sine is y. This is negative root 3 over 2. Cos is x, negative 1 over 2. And when you divide it, negative divided by negative, okay, y over x is going to be positive, root 3. Cosec is a negative, because it's 1 over y, negative 2 root 3 over 3. Sec is a negative, negative 2. Cotan will be x over y, negative divided by negative, which is positive, root 3 over 3. Alright? Last but not the least, 300 degrees. 300 degrees, 5 pi over 3. So, sine is y, negative root 3 over 2. Cosine is x, 1 over 2. Tan, y over x, so something is negative. So this will be negative root 3. 60 being the reference angle, which is great. You know, reference angle are all positive, so you could easily get it from the reference angle of 60. Cosec is 1 over y. Y is negative, so this will be negative. Negative 2 root 3 over 3. Sec is 1 over x, and x is positive, so this will be 2. And then cotan is x over y. This should be negative. Negative root 3 over 3. So you see it, and you see the equivalence. Okay, I think we've got all these special angles. If you look at it, if you do it yourself, you'll see we've got all of them, all the trigonometric functions of special angles. I know I defined reference angle, but I don't know whether I wrote it down. So I guess I didn't write it down. So let me go ahead and write down the definition. Reference angle is defined as the positive acute angle that the terminal side of an angle drawn in standard position makes with the x-axis. Now the terminal side of an angle drawn in standard position, and this is just one form of definition. I mean, you could define it your own way. Drawn in standard position, comma, makes with the x-axis. It could be positive x-axis or negative x-axis. Another way you can define it is, given an angle drawn in standard position, the reference angle is defined as the positive acute angle which the terminal side of the angle makes with the x-axis. Define it your own way, okay? Alright, I think these three parts have covered the trigonometric functions of special angles. So please check it out with a calculator. Know the easiest way of converting to pi, converting to radians, okay? In terms of pi, know the easiest way of doing it. If you can either use proportion, like we did, or you could check the multiple of special angles.